All right, so we're going to go ahead and move on to graphs of circles. When we talk about circles, there's two really important things that we need to know, and that is the center point, okay? We call this the center, and the center is always denoted with HK, okay? So anytime you see HK, we're referring to the center point of a circle. And then how a circle is defined is we take a radius length. Okay, so whatever this r length is, we go out r units, and every point that happens to be r units away from that center make up all the points of our circle. Okay, so if we know the radius of our circle and we know the center point of our circle, then we can write it in standard form, we can graph it, we can solve some things with it. So those are the main things, is to make sure we know that the center is HK and that our radius is that length that tells us how far away the points of our circle are from that center point, okay? Now, once we know those things, then we want to be able to write a circle in the standard equation for a circle, okay, or the standard form. Now, this is something that you'll need to know for your Unit 10 exam. This will not be given to you with that exam, but this will be a formula that is included for the final exam formula sheet, okay? So most importantly, notice here we have a squared quantity for our x's. We do x minus that center x value of our circle, right? And then we have y minus the k value, which is that center y value squared, equals our radius squared. And this actually is derived from the Pythagorean theorem. We're talking about the distance change in our x's. We're talking about the y change vertically. And then we take the square root of that to figure out what our r value is, okay? We're not going to get into a lot with doing distance, midpoint, things like that with our circle, but I do want to make sure that you know how to write it in standard form if you are given the center and the radius. And then also, if you are given the standard form, how to take the center and the radius from that. So notice here, this is a center point, which is a positive h and a positive k. And notice when we write it in the formula, there's a negative h and a negative k. That's because we're subtracting that center point to find that distance, okay? So when you look at an equation, you're going to be looking at these two values to identify your center, and then the number that's being squared gives you your radius, okay? Not radius squared, not r squared. This whole thing is not your radius, just the number that's being squared, okay? So for instance, if I had something like x plus 3 quantity squared plus y minus 4 quantity squared equals 9, okay? Something like this. Notice in our equation, it's supposed to be x minus my positive h value, right? So I want to know, what does my h value have to be here if when I subtract my h value, right, when I subtract my h value, if I'm left with a positive 3? Well, that would mean that my center point, right, I look at these 2 points to get my center point would have to be a negative 3, right? Because a negative 3 is what I would plug into this formula, and when I subtract a negative 3, that's what would leave me with a plus 3 inside that quantity, okay? Same thing on this one. What do I have to subtract from y to end up with a negative 4? Well, I would have to subtract a positive 4. Oops. Okay. So you can think about it as this: what am I having to subtract? Or you can just remember that whatever the signs are in the equation, they are flipped in the actual center point. Okay. And then here, notice 9 is not written as a number squared. So if there's just a regular number written out here, to find our radius, we're trying to figure out what number squared would give me 9, right? And we know that 9 is the same thing as 3 squared. So here our radius would be 3. Does that make sense? Okay. Or you can think about taking the square root of this number out here to figure out the radius. Okay. So this is some stuff we'll do later on. I just wanted to give you a little example so that you can see the center point and how it appears in the formula the signs will be flipped, will be opposite, okay? Just like here we had a +3 and a -4 in the formula, our center point is -3 and +4, okay? So let's start off with just being able to find the standard equation of a circle given the center and the radius. So if we're given the center, that means this is my H, this is my K, our radius is 7, so that's my R. So I'm just going to take H, K, and R and plug it into this formula. Now, when you're trying to get familiar with a formula, the more you can write it and say it, the more you're going to remember it. So I'm going to go ahead and write X minus H quantity squared plus Y minus K quantity squared equals R squared. Okay, so this is what we want to end up with. So let's go ahead and plug in our values. So we have X minus our H value, which is -6 quantity squared, plus Y minus our K value, which is 1 quantity squared, equals our radius, which is 7 quantity squared. Okay, and then all we have left to do is to simplify this a little bit, right? Double negatives on the inside here are going to make this an X plus 6 quantity squared. And then I'm going to go ahead and multiply my 7 squared, which is 49. So this is the standard form of a circle. Okay. Now I will tell you in Newton there are some multiple choice problems where they do not multiply out the 7 squared. They'll just leave it as 7 squared instead of writing 49. I prefer that you go ahead and square it, but I just wanted to mention that so that if you see that on Newton as you're doing your homework, that's okay. Okay. All right, let's look at another one. We're given the center, so this time our H is 8, our K is -2, and our radius is square root of 13. So this is my R. So again, if I want the standard form of a circle, I want it to look like X minus H squared plus Y minus K squared equals R squared. And then I'm just going to plug in all my values. So X minus my H, which is 8 quantity squared, plus Y minus my K value here, which is -2 quantity squared, equals my radius, which is the square root of 13 squared. Okay. So I go ahead and simplify this. So I end up with X minus 8 squared plus Y plus 2 quantity squared equals, and then remember when I square a square root, those are inverse operations, right? So they cancel out. So I would just be left with a 13 over here. Okay. All right. So maybe not too bad. Let's go ahead and look at the opposite direction now. Instead of being given the center and the radius and just plugging them into the standard form, we want to be given the standard form and see if we can pull our center and our radius from that equation that is given. Okay. Let's go ahead and look at our second page here. All right, it says for each of the following, identify the radius and the center and then use them to graph the circle. So I want to go ahead and look at this. This is standard form, right? So I know that this value right here, this is the same thing as saying X minus what type of number, right? If I end up with X minus H here, then I would have to be subtracting a -4, right, in that squared quantity, which means that my H value is -4, okay? Here we're doing Y minus our K value, so this tells me that my K value is 3, so that means that my center is the point -4, 3, or again, you can just remember however their signs look here, we're going to flip them for the center, okay? So this is the center. And then we know that our radius is equal to, well, in our equation, this is our radius squared. So if this is our radius squared, then our radius has to be 3. Okay. Once we've identified our center and our radius, now we should be able to graph it. So we go ahead and plot that center point, which is at -4, 3. I'm going to go ahead and plot that center point. And then we know our radius is 3. So that basically means we want to go out 3 in all directions, right? So we can get a nice circle around this. So it's harder to do it on an angle. So I'm just going to go up like north, south, east, and west 3 units. So to the right 3, up 3, to the left 3, and down 3. So I'm going to get those 4 points. Now when I connect these, I don't want it to look like a diamond or a square on its side, right? So go ahead and try your best to connect to these in a circular motion, okay? So that is our circle. Okay, let's look at another one. Same thing here. First thing I do is identify my center. So I'm looking at these two values, right? And they are flipped how they appear in our equation. So this means that my center is going to be 5, positive 2, right? And then remember, this number over here is radius squared. So I need to figure out what number must I square to get 16, right? Or you can actually solve this. You can say r squared is equal to 16, and then you can take the square root of both sides, right? Square root of r squared equals the square root of 16, which means that r equals 4. Okay. The biggest mistake I see with these problems is people squaring 16 to find the radius versus taking the square root of 16 to find the radius. Okay, so make sure you know the difference. So now that we know our center is 5, 2, and we know our radius is 4, we should be able to graph this one. So we're going to go to the right 5 and up 2, put our center point, and then we're going to go out a radius of 4 in all 4 directions, right? So 4 to the right, 4 up, 4 to the left, and 4 down. And then once we have our 4 points, again, we're just connecting these as best we can in a circular motion. Okay. All right. So these, we pulled our center point and our radius from the equation and graphed it. I want to look at one more type really quickly, and that is when we are given the actual graph of the circle and we want to find the equation of the circle. Now, anytime we want to find the equation of the circle, we should be thinking of that formula, x minus h squared plus y minus k squared equals r squared. Okay, this is what we want to come up with when it asks us for the equation of a circle. Now, in order to know this, we need to know what our center point is. We need to know our HK, right? And we need to know our radius, which is R. So we should be able to figure out our center and our radius just by looking at this picture, okay? The center point has an X value of -2 and a Y value of -5. Okay, so this is the point, -2, -5. I'm just going to write it here, -2, -5. And then our radius is the distance from our center point out to the edge of our circle. So I'm just going to draw a line straight across so that I can count that distance. So if I count my units, I have 1, 2, 3, 4, 5. So that means that my radius is 5, right? Radius is equal to 5. So now that I know my center point and I know my radius, now I can go ahead and plug it into my formula. My formula says to do x minus my h, which is -2, quantity squared, plus y minus my k, which is -5, quantity squared, is equal to my radius, which is 5 squared. And then all I have to do is simplify that. So I end up with x plus 2 quantity squared plus y plus 5 quantity squared equals 25. And this is the standard form of my circle. Okay. All right. So on the next page, there are 2 for you to try. So go ahead and pause the video and give those a try. And then whenever you are ready to be checked, or if you get stuck, unpause the video and we'll go over them. All right, so looking at these practice problems, we can see here our h value and our k value and our r value from the equation. Remember, the h and k, the signs are flipped from what they look like in the equation, which means that my center point is -3, -2, and then my radius here we can see is 5. So I just plot the point -3, -2, and then I go out 5 units in all 4 directions and draw my circle. Okay, not too bad. On the second one, the circle is given to us and we have to come up with the standard form. So we have to identify our center point, which in this case is 3, -1. And we have to identify our radius, which is the distance from our center out to the edge of our circle, which in this case is 6. And then once we know our center point and our radius, then we're just plugging it into the standard form of our circle. Okay, so we should end up with quantity x minus 3 squared plus quantity y plus 1 squared equals 36. Okay, everybody all right? Okay, so when we're dealing with circles, we always want it to be written like this, because if we can have it written in this form, we can easily identify the center and we can also easily identify the radius. Unfortunately, they don't always give it to us in this form, right? They may just give it to us in general form, which means we have x terms, x squared terms, y squared terms, and constant terms. So what we're going to look at next is how to go from a general equation that has x's and y's and craziness and get it written like this. So our goal is to end up with a squared x quantity, a squared y quantity, and a constant term over here. Okay, so let's look at how we're going to do that. We're going to use completing the square. And here are our steps. I'm going to read through them really quick and then we'll just kind of talk about them as we go. Okay, so the first thing we want to do is make sure all of our x terms are written together and our y terms are written together. Because if we can have them side by side, it just makes our life a little bit easier. Okay, and then we want to leave the constant term on the other side of the equation. Or if it's not on the other side, we want to move that constant term to the other side because we don't use it to complete the square. Okay. Now, because we're going to be completing the square, we have to make sure our leading coefficient is a 1. Okay, so if there's any number in front of the x squared term, any number in front of the y squared term, we have to divide that off. Okay, and we have to divide it off of every single term. We can't just divide a number off of one term. Okay, so make sure my x's and y's are together. We're going to move our constant to the other side. We're going to divide off any leading coefficient we have, and then we can go into completing the square. And the way that we completed the square is we took half of the variable coefficient, so half of the x term coefficient or half of the y term coefficient, right? We squared it and we added it to both sides, okay? And we do this for both our x and our y. So we're kind of completing the square twice, okay? All right, now this should simplify to two perfect squared quantities, okay? One, meaning that we end up with something like this, a squared quantity here and a squared quantity here. And then all we have to do is simplify that right-hand side, okay? So let's look at an example so that this sort of makes more sense. All right, so here is our standard form, our general form of this equation, and we want to get it into standard form, which means we want to end up with this. Okay, this is our ultimate goal. So first thing we do is make sure our x terms are written together, and here you can see our x's are together, our y's are together, but we have this 2 that we don't need. So I'm going to go ahead and move the 2 to the other side by subtracting. Okay, and I'm going to write over here, move constant term. Okay, so when we move our constant term, that leaves us with 2x squared plus 8x plus 2y squared plus 4y equals -2. Okay, then we need to make sure our leading coefficient is a 1 because we can't do completing the square unless the leading coefficient is a 1. So notice here my x squared coefficient is a 2, my y squared coefficient is a 2. So I'm going to just divide every single term by 2, which is totally legal as long as you do it on both sides of the equation sign. Okay, so I'm just going to say make leading coefficient 1. Okay, because we can't complete the square until our leading coefficient is a 1. So now we're left with x squared plus 4x plus y squared plus 2y is equal to -1. Okay, so now we can complete the square, and we're going to do it with x's and y's separately. Okay, so I'm going to think about there just kind of being like a little division between those two. Now, when I complete the square with my x's, the way that I do that is I take half of my x term coefficient. So my x term coefficient here is a 4. When I take half of 4, that gives me 2. Okay, so this is what I'm going to be squaring and adding to both sides, right? So this gives me x squared plus 4, oh, I keep breaking my lead here, plus 4x plus that 2 squared. Now, if I add 2 squared to this side of the equation, I also have to add 2 squared to this side of the equation. So I'm going to go ahead and write over here. We already have that equals my -1, right? That's already on that side. But if I add 2 squared to this side, I have to also add 2 squared to that side, okay? So now I'm done with my x's. I'm going to stop for just a second. Well, actually, I'm going to simplify. So I have x squared plus 4x plus 4. Okay. Actually, let's just keep going. Let's go ahead and finish this out because remember, I want to end up with an x squared quantity. So then this should be something that factors. So I'm going to check it with my sum product chart. My sum is 4, that's my middle coefficient, and my product is also 4 because I do my first coefficient times my last. So something that sums to 4 that also multiplies to 4 would be 2 times 2, right? And I can use my shortcut here because my leading coefficient is a 1. So that means this factors into x plus 2 times x plus 2, or the way that we want to write it is x plus 2 squared. Okay, so that was all getting my x's done. Now I want to do the exact same thing with my y's. Okay, so I'm going to complete the square with the y's. So I'm going to take half of my y term coefficient, which is a 2. Half of 2 is 1. So 1 is what I'm going to square and add to both sides. So I have my y squared plus 2y plus now this 1 squared, right? And if I add 1 squared to this side, I also have to add a 1 squared to this side, okay? So now let's go ahead and simplify here. So this becomes y squared plus 2y plus 1. I'm hoping to get it as a squared quantity, right? So I'm going to go ahead and factor it. My sum is 2, which is my middle coefficient, and my product is my leading coefficient times my last coefficient, which is 1. So what can I sum to get 2 that I can multiply to get 1 would be positive 1 and positive 1, right? And again, because my leading coefficient is a 1, I can use my shortcut. So this factors into y plus 1 times y plus 1. Or the way that we want to write it, y plus 1 squared, okay? And then I want to go ahead and simplify this side of the equation, right? When I simplify this side of the equation, I have, let's see, -1 plus 4 plus 1, and then my 1's are opposite, so those are going to cancel, and I should just be left with 4. So this is the standard form of my equation of this circle, okay? And then I'm going to go ahead and just identify the center and the radius. Why not? Okay, our center, remember, we pull from these middle numbers inside my squared quantities, and the signs are flipped. So this means my center is -2, -1, and my radius is the number that I have to square in order to end up with this number. So the number that I have to square to get 4 is 2. Or you can think of the square root of 4 is 2. Okay. Now I know this problem didn't ask for that, but it's always good to just make sure we can identify these things. Okay. All right. So let's go back over this because there are some parts that I am not going to require you to do. So let me see if I can find. Okay, here we go. All right. So anytime we're completing the square, we want to make sure our constant is on the other side and that our leading coefficient is a 1. Okay, so once we have it written like this, this is the point at which we can start completing the square, right? We take half of the x term coefficient, which in this case was 2. Now I just want to highlight this. I just want to highlight this 2 right here, okay, because that's important. Notice after we took that 2 and we squared it and we added it to both sides, once I simplified this whole mess, 2 is what I ended up with in my factored quantity, right? Whatever I got when I took half the middle term is what I get in my squared quantity. And we talked about this shortcut back when we did completing the square, which means if you can remember that, you can leave out all of this work right here. You don't need to do all of this. You can go straight from, I took half the middle term and got 2, and so I know this side is going to factor into x plus 2 squared. Now, the one thing you do have to remember is that you have to square that 2 and add it to the other side. So if you use this shortcut, that is the one thing you have to remember, is that once you find this 2 and you use the shortcut to get it in the squared quantity, you still have to square the 2 and add it on the right-hand side. Okay? Same thing is true with the y's. Notice whenever we completed the square with the y's, we took half of the y term coefficient. So half of 2 gave me this 1, right? Again, I could skip all of this and just say, okay, this is going to factor into x plus 1 quantity squared. Okay, but in order to make sure I get the correct number over here, I still have to take that 1, square it, and add it to the other side. So this is how I'm going to work it, excuse me, moving forward. Instead of actually going through this whole factoring process, which you are more than welcome to do, once I take half the middle term, I'm going to just jump right down here, write my squared term, and then square that number and add it to the right-hand side, okay? Because it saves us doing all this stuff, okay? All right, so let's look at another one. Same idea, but this time using kind of our condensed shortened version. So we have x squared minus 6x plus y squared plus 8y plus 5 equals 0. First thing I want to do is move that constant to the other side. And notice it is being added. So when I move it over, I'll move it over with subtraction. So I'll have x squared minus 6x plus y squared plus 8y. Oh, excuse me. Equals negative 5. Because when I move that 5 over by subtracting, it will become a negative on the other side. Okay. Now I want to make sure that my x terms are written together, which in this case they are, and that my y terms are written together. In this case, they're both written the way I want them, and the leading coefficient is already a 1. So I can go ahead and go straight into completing the square. Okay, so remember, I'm going to complete the square for the x's, and I'm going to complete the square for the y's. So when I complete the square for the x's, I'm going to take half of that x term coefficient. So half of negative 6 gives me negative 3. Okay, so remember, with that negative 3, I can go ahead and jump down and say, okay, well, this side's going to factor into x minus 3 quantity squared. Okay, but I also have to remember to add a negative 3 squared to the other side. Okay, so take half the x term coefficient. That gives us the number that goes inside our squared quantity and the number that we're going to square and add to the other side. And now I want to do the same thing with the y's. I'm going to take half of the y term coefficient. So half of 8 is going to give me a 4. So that 4, excuse me, tells me that this is going to factor into y plus 4 quantity squared. Okay, so whatever that number is, that's the number that shows up inside my squared quantity, and it's also the number that I need to square and add to this side. Okay, so those are the 3 things we have to remember. Take half the middle term, stick it in our squared quantity, square it, and add it to the other side. Okay, all right, so here's what we end up with. X minus 3 quantity squared plus y plus 4 quantity squared equals, and then we just have to simplify what's over here on the right-hand side. So we have a negative 5, we have a positive 9, and we have a positive 16. Okay, so we just need to simplify those values. So I have x minus 3 quantity squared plus y plus 4 quantity squared equals negative 5 and 9 leaves me with a positive 4. Positive 4 and 16 gives me a 20. So this is the standard form of my circle. And then I'm going to go ahead and identify my center and my radius. Okay. I can easily see here that my center comes from these two numbers, but I changed their sign. So I end up with a +3, -4 center. Make sure you write that as an ordered pair with parentheses, okay, because it is a point on the graph. And then to find my radius, it's kind of hard to figure out, okay, what do I have to square to get 20? Because 20 is not a perfect square. So I'm going to come over here and just write, this means that r squared is equal to 20, right? That's what this formula said, is that this is r squared. So if I want to solve for r, I would take the square root of both sides, right? So that means that r is equal to the square root of 20. And then I just want to see if I can simplify this at all, right? To simplify a radical, we need a perfect square, right? And 20 itself is not a perfect square, but it might have a perfect square within it. 20 is the same thing as 4 times 5. 5 is not a perfect square, so it's going to be stuck under the radical, right? But 4 is a perfect square. That comes out as a 2, right, when I take the square root of 4. So this means that my radius is the same thing as 2, because I brought that out because of the 4, times the square root of 5. Okay, I don't think Newton gives you any problems like this where the radius doesn't come out to a nice pretty number, but I wanted you to see one in case you encounter this later in life, right? It's a good thing to be able to take a number that you know equals r squared and figure out what r is. Okay, so here's my center and my radius. Okay, so again, when we're completing the square, we move the constant term, we divide off any leading coefficient, then we go straight into completing the square by taking half the middle term. Whatever we get when we take half the middle term, those numbers go into our squared quantities. And then also the numbers we get when we take half the middle term are the numbers that we are going to square and add to the other side. Okay, let me look at one more and then I will have y'all try some, and then that's the end of our section. Okay, all right, so again, first thing we want to do, make sure our x's are written together, make sure our y's are written together, and we want to move this constant to the other side. Okay, and we're going to do that by subtracting. So we get 3x squared plus 30x plus 3y squared minus 12y. And when we move that 12 over, notice it's being added. So to move it, we would subtract. So it's going to be a -12 on the other side. Okay. Then we have to make sure our leading coefficient is a 1, because if it's not a 1, we can't do completing the square. Okay. So notice here our leading coefficient for our x's is 3, and for our y squared it's 3. If there is something to divide off, it will be the same on both the x squared and the y squared term. Okay. You'll either have just x squared and y squared and you won't have to divide anything off, or what you divide off will be the exact same number on both. Okay, so we're going to go ahead and divide everything by 3 so that our leading coefficients become 1. So that's going to leave us with x squared plus 10x plus y squared minus 4y equals -4. Okay, make sure you divide off the 3 on the other side. That's the only way we can do it, is if we divide everything by 3. Okay, all right, so now we have our constant on the right side. We have our x's together, our y's together, so now we can go ahead and complete the square. So for our x's, we're going to take half of our x term coefficient, which is 10. Half of 10 is 5. So we're going to go ahead and take that 5 and we're going to put it in our squared quantity. So this is going to be the quantity x plus 5 squared. Notice whatever the sign is that we get when we take half of the middle term, that's also the sign that shows up here. So if this would have been a -5, we would have put x minus 5. Okay. All right. And then we also need to take that 5 and square it and add it to the right-hand side. So we're going to add 5 squared over here. Okay. Then we want to do the same thing with the y's. So when we look at the y's, we take half. Oh my goodness, I am having lead issues today. 1/2 of our y coefficient, which in this case is -4. Half of -4 is -2. So we can use our little shortcut here. We know this is going to be the factor y minus 2 squared, right? Because whenever we take half of our y term, we got negative 2, which means negative 2 goes in our squared quantity, and negative 2 is what we're going to square and add to the right-hand side. Don't forget to add it to the right-hand side, okay? All right, so we have our 2 squared quantities on the left-hand side, and then on the right-hand side, we just need to simplify these. So we have the negative 4 that was already there, the 5 squared, which gives us 25, and the negative 2 squared, which gives us a 4. Notice here we have a negative and a positive 4, so those are going to combine to 0. So we end up with x plus 5 quantity squared plus y minus 2 quantity squared equals 25. Okay. All right, so that is the standard form for our circle. And then again, I want to go ahead and find the center and the radius, not because the problem asked me to, but just because it's a good habit, right? So our center comes from these two numbers inside our squared quantities. We flip the signs. So our center would be negative 5, positive 2. And then our radius comes from this number, right? Remember, this number over here is our radius squared. So if our radius squared is 25, if we take the square root of both sides, then that means that our radius would have to be 5. Okay. And notice when I'm solving for the radius, even though I'm taking the square root, I'm not doing the plus or minus. That's because that radius, remember, represents the distance from the center point out to one of the points on the circle, right? It's a distance. So if it represents a distance, we don't have to worry about the negative, right? Because we can't have negative distance. All right, so on the next page, there are 2 for y'all to try. Go ahead and give those a try. If you get stuck or you need help or you completed them and you want to check yourself, go ahead and unpause the video and we'll go over them. All right, so let's look at these practice problems. On number 1, first thing we do is move that constant term over. So we have a positive 78 when we move it over. Then we have to get rid of our leading coefficient. So we divide everything by 3, right? Then we're going to we're going to complete the square. So when we complete the square with our x's, we take half of our x term coefficient, which is a negative 1. Our negative 1 is what shows up inside our squared quantity. It's also what we're going to square and add to the right-hand side. Okay. Same thing with our y's. When we take half of our y term coefficient, half of negative 6 gives me negative 3. So negative 3 is what shows up inside my y squared quantity. Negative 3 is also what we're going to square and add to the right-hand side. Okay. All right. So notice I have a 26 here. I had somebody ask me about this in class. So remember, when we divide off the leading coefficient, you have to divide off 3 on the other side. That's where we're getting the 26, okay? And then we add our squared numbers to the 26. We end up with 36 on this side. So we get x minus 1 quantity squared plus y minus 3 quantity squared equals 36, which means that our center point is positive 1, positive 3. And our radius, the number we have to square to get 36, would just be 6. Okay? If you need more time on that, feel free to pause the video or go back. I'm going to go ahead and move on to number 2. All right, so number 2, first thing we do again is move our constant term to the other side. So that's going to make it a negative 12. Okay? Then we have to divide off any leading coefficient we have, which here is a 2. So we divide everything, including that constant term, by 2. So now our x's are together, leading coefficient of 1. Our y's are together, leading coefficient of 1. And it's equal to negative 6. So now I can go ahead and complete the square. So when I take half of my x term coefficient, which is 10, I get 5. When I take half of my y term coefficient, which is negative 8, I get negative 4. So that means that these two numbers, 5 and negative 4, are going to be the numbers inside my squared quantities, right? They're also going to be the numbers that I square and add to the other side, okay? So we have our quantities looking the way we want over here. On the right-hand side, we just have to simplify our squared numbers. So negative 6, 5 squared gives me 25. Negative 4 gives me 16. When I combine all of this, I get 35. 35 is not a perfect square, right? So to find r, when we're given r squared, we're just going to take the square root of 35, right? And notice here, I left it as the square root of 35 because 35, when I try to factor it down, is just 5 times 7, right? And 5 is not a perfect square, and 7 is not a perfect square. So there's nothing I can bring out side of the radical to simplify. So I'm just going to leave it as the square root of 35. Okay? All right, so that is the end of this section. So you should now be able to complete graphs of circles in your in your Alton Newton homework. And if you have any questions, please let me know.